used a Linux system before and has their access IDs ready, because these are the prerequisites that we have for the course. If anyone does not have an access ID, please let us know in the chat. Also, is everyone able to see my screen? I hope all the participants are able to see my screen. So, okay, let's start with an introduction to ACES first. So ACES stands for Accelerating Computing for Emerging Sciences. This is a Dell cluster with rich accelerator testbed. So we have numerous compute nodes on this. We have the Intel Sapphire Rapids nodes. We have the Intel Ice Lake nodes. Uh, we have plenty of accelerators. We have NVIDIA H100 GPUs, the A30 GPUs. We have Intel Optane. We have Intel GPU Max 1100. And the Intel Optane SSDs and all accelerators are accessed using Liquid's Composable framework via PCIe Gen 4 and Gen 5 fabrics. All of these are very technical terms. So if you guys want to check for more details, you can go to the website link that we have in the slide. And this is part of our knowledge base. Coming to FASTER, FASTER stands for Fostering Accelerated Sciences Transformation, Education, and Research. This is a 180 node Intel cluster from Dell with an InfiniBand HDR100 interconnect and Liquid PCIe Gen 4 for composing the GPUs. We have NVIDIA A100, A10, A30, A40, and T4 GPUs available. And we have three different types of nodes that is available to the users. We have the login nodes, we have the compute nodes, and the large memory. So based on your requirements, you can use the nodes. And for more details on FASTER, you can again visit our knowledge base and visit the link which we have provided in the slide. Now coming to the ACES design, so I'm gonna talk about the composability at the hardware level. So traditionally the servers used to be rigid, so they would have like strict configurations. Like you can see that in traditional servers, you would have maybe one accelerator and one SSDs, or two accelerators and one SSD. So those were fixed. But now we have pools of servers, we have pools of accelerators, and we have memory pools. So from these pools, you can compose server configurations to your needs. So for example, you can see on the right that for in a server, you can have maybe 3 accelerators and 1 SSD. Maybe you want more accelerators uh, and still the 1 SSD, or maybe you don't need SSDs and you only need the accelerators. So you can compose your servers however you want. So we have a little pop quiz for you guys. So which accelerators are available on ACES? Please, you can let us know in the chat. We'll probably wait for a minute here to see all of your answers. Okay, I think most of you have got it right. So we have Intel PVC, H100, Graph Core, IPUs, A30, all of these accelerators are available on ACES, and you guys can use it to do your research work using these accelerators. Now, coming to the portal, so our HPRC webpage looks like this. So you can just do a Google search of HPRC TAMU, and the first link you will get is probably of our website. So you can just visit that link, or you can visit our webpage through this slide. And on the web page, you would be able to see this navigation bar where you will see the option of portal. So if you click on the portal, you will see access to a different sets of clusters that we have. So you can see that you can see faster portal here, you can see ACES portal here. So for faster, you need your TAMU net ID. But if you're not a TAMU user, if you have an access ID, you can access the faster cluster using your access ID. Same goes for ACES. You can use ACES using your access ID. And these are the links provided in the slide to access these clusters. So I'm just going to give you guys a demo on how to access these clusters. So if you go to the HPRC website, this is how it should look. And then if we go to the portal, we are able to see the options here. So this faster portal option, this is for the TAMO users. And then the next faster portal access, if so, you can, if you want to access the faster portal using access ID, you click on this option. And for ACES with access ID, you click on this option. So for here, I'll show a demo on ACES portal, how it looks like. So if you click on here, it should take you to the portal. This is how our portal looks like. Coming back to the presentation. So this is exactly how our portal we just saw looks like. And now if you want to access the shell, so you will have to go and click on clusters, and then you can click on ACES shell access. So this will start an in-browser terminal for you to interact with the resources that we have on our clusters. So I'll give a demo on this as well. If you go back to the portal and click on clusters, you should be able to see this option here. And if you click on this, you should be able to visit this shell, and you should be able to see such output. So going back to the presentation, actually, before I proceed, I want to know if you are able to follow till here. Like, is anyone having any trouble accessing ACES portal? And if you're able to access the ACES portal, can you give acknowledgement in the chat? Okay, I think you guys are able to access it. So we'll go ahead. And so coming to faster, so to access faster, you can use SSH. So SSH allows users to establish a connection between their local machine and the HPRC clusters. So if you're on Mac or Linux, you can simply use your terminal and just SSH into the clusters. If you're on Windows, you can use applications like MobiXterm, PuTTY, WSL, or the command prompt, or even the PowerShell. So you open these programs, and in the terminal, you just provide this command. So it will be SSH your net ID @faster.hprc.tamo.edu. And once you hit enter, it should ask you for your password, your TAMO password, and it should ask for a duo authentication. So once you complete these steps, you should be able to access our faster cluster. For users who are trying to access it off campus, you should have VPN. And for users who are not TAMO users, you should use your access ID. And for that, you can go to the knowledge base and go to this web page to gain more knowledge on how to access faster using the SSH. Now, one thing you might want to keep in mind is that ACES is not accessible using SSH. You can only access it using the portal that I showed you a few slides before. Going ahead, so I want you guys to try this out. So go to the ACES portal, open the shell, and let me know if you guys are able to see the output how I showed you. Just for your reference, the output should look like this. You should be able to get an output on your terminal like this. So please let me know in the chat. I'll be waiting for a
Hi Akash, this is Mohammed. I just have a quick questions.
Sure.
I accessed the faster portal from the HPRC website and it worked fine. But when
Okay.
I tried to access the ACES, it didn't go through, even though I'm not on campus, but I have the VPN on. And then I tried it with the incognito mode in the Google Chrome, and then it worked. So can you please comment on that? I mean, why did that happen?
What was the issue that you faced with ACES?
So when I tried to log in into the normal, Chrome window,
Yeah.
so it gave me some error. Let me just yeah, try it again and see what was that. Yeah, so it says like the bad request or your browser set a request, or I mean, it looks like it's some kind of like a browser's issue. But when I tried it into an incognito mode, so it went through and I was able to get this window that you have on the screen.
Okay. It
Uh,
could be a
so
cache issue, but I'm not sure on that. If it's working in your incognito, I think it should work in normal mode also.
So when I try to access the faster portal, normal actually is without the access, so it is working on my
Yeah.
system.
Yeah.
Uh, but I think access is only working in the incognito mode.
Okay.
So I'm just trying to understand.
Um, are you trying to are you trying to reach out to the correct link? Like, so we have different links for the faster and faster through access.
Yeah, so like the faster through normal connection from the HPRC website, it's working, but faster through access, it's not
Yeah.
working
I
in the
think
normal window.
maybe you could try to delete your history or maybe the cookies and try it again. Maybe it could be that
Okay,
because if it's working in your incognito, it could be a cookies issue,
all
but
right.
we're not sure exactly. But yeah, maybe you can try that out. And if you're still having issues, just let us know.
Yeah, I'm using it in incognito mode. I just trying to understand.
Okay.
Yeah, thanks.
Yeah. Okay. So let's get back to the presentation. So now coming to the file systems and user directories. So you guys will probably want to store your files and your on our cluster. So we have two types of directories here. One is the home directory and one is the scratch directory. So the home directory has a space limit of 10 GB and a file limit of 10,000. So mostly you'll be storing small files here. And if you want to do bigger computations, you can use Scratch directory for that purpose. The space limit on Scratch is 1 TB and the file limit is 250,000. So the Scratch is directory is shared between Faster and Grace. Keep in mind that I'm only talking about Faster in this slide. The Scratch folder in ACES does not share the file system between the other two clusters. And to view the file usage and quota limits, you can use the command show quota. So you can just go to your terminal and run this command, and you should be able to see how much of the limit you have used. Also, for more information, you can always visit our knowledge base, and you can just visit this web page that we have linked in our slide to get more information. So in the portal, if you want to view the same thing, you want to see how much of the file limit or the disk limit you have used. So you can just go to the dashboard and click on ACES dashboard and it should show your account quota and projects. So I'll just give a demo on this. So if you go back to the portal and you click on dashboard and click on ACES dashboard, it should give you a different dashboard where you can see all of your account details. So you should be able to see your allocations, how much you have used, how much is the balance right now. And you should also be able to see your disk quotas. You're able to see how much disk quota amount is there for each of the directories. And I want you guys to just repeat this activity with me so that we know that you guys are able to see this page as well. So moving on, we go back to the presentation. Another thing, what you can do is, so in the dashboard, you should be able to see this request quota increase. So if you want to increase the quota limit, so say the limit of the disk is 1 TB, but maybe you need 5 TBs for your project. So you can just click on this request quota increase and fill up the form, and that should and submit it, and we should be able to get the request and we'll process it, and within no time your disk limit or whatever quota increase you want should increase. I'll just give a demo on that as well. So if you go to the dashboard and if you click request a quota increase, so you should you'll get this, and if you just for the demo purpose, you just have to fill up these forms. You can provide your email ID. Current quota is this, so you just provide a new quota you want. The current file limit, just provide a new file limit you want to request, and just fill up each of these boxes. That just helps us in making a request get complete faster. So you can just submit it here, and then we'll process your request. So coming to the software part, so we have plenty of softwares available on our clusters, and if you want to know which softwares are available, you can visit these web pages. So you can go to our knowledge base and check out what softwares we have available, and for each of these clusters, we have a separate web page where you can check it out. And for license restricted software, you can always contact us at help@hprc.tamu.edu and just contact us for any software installation or any help on those. And if you want to install a software yourself, you can do it in your home or scratch directory, but do not run the sudo command when you're installing the software. So the installed applications are made available with the module system, and the ACES uses a software hierarchy inside the module system. And in this hierarchy, the user loads a compiler toolchain, which then makes available software built with that compiler toolchain. So these are few of the commands that you're going to be using to load softwares and to interact with the softwares that are available on our clusters. So you can, in your terminal, you can just run module list to see which softwares are already loaded in your cluster. You can do module load and the name of the application or the software you want to load. So once you run this command, that particular software will be ready to use for you. If you guys want, you can try these commands out. And then once you do a module load and you do a module list, you should be able to see that the GCC software has been loaded. Now, talking about modules and toolchains are what we call groups of compilers and libraries. There is a variety of toolchains on the cluster. So we have the Intel, we have FOSS, we have GCC Core. And to do module management, you can use these two commands. So module spider helps you search for modules on our clusters. So say if you don't know if we have, say, Python or OpenMPI available, you can use module spider and then the module you want to search for, and it should give you a result of the available softwares which match your query. And module purge removes all of the loaded modules. So in the previous slide, you saw that we were loading GCC or we were loading OpenMPI. So if you do module purge, it will remove all of those loaded modules. So I want you guys to just try this activity. So you can search and load this module, and then you can also remove this module to see if you're able to use all of these commands that we have just went. If you guys are facing any issues, let us know in the chat. We're here to help. Okay, I'm assuming that everyone was able to do the activity, and let's move ahead. So coming to batch computing on our HPRC clusters, So we have already covered, so if you see this diagram, we have already covered the left part of the diagram where I've already explained how the on-campus user can access our clusters, how the off-campus user can access our clusters, and how the access users can access our clusters. So once you're able to SSH into our cluster, you're basically on our login nodes. Sure, Google. Uh, So if you want to load GCC, so what you need to do is you can do module space load space GCC slash 12.3.0, and that should load this module on your cluster. So this is the command you would like to use, and just change the version number. So okay, getting back to this slide. So once you're on the login nodes and you want to create a job, so first you would need a job script. So a job script is a text file that contains some Unix and software commands and batch manager job parameters. We'll be introducing you to those parameters soon. So once you have the job script, so you will submit your job, which will get queued in the Slurm, which is our batch manager. And once your job gets executed, it gets executed on the compute nodes. And once the execution is completed, we get some output files, which is useful for our research. So moving ahead, the job submissions are auto-assigned to batch queues based on resources requested. So since a lot of users are there on our clusters, so sometimes it might take some time for your job to get assigned. So it might be waiting there in the queue. So do not worry about it. Your job will get executed. So for more information on how you can run, how you can submit batches, you can just go to this web page and get more information. Now, coming to the thing which is new in our clusters, we have a tool called Drona Composer. So this makes job submissions super easy. So if you don't know how to write a job script, you can just go to our ACES portal, and in the navigation bar, you will be able to see an option called Jobs. From there, you can select Drona Composer, and you should be able to see a page like this on the left. And here you are able to select any environment that you want to set up for your job script. You can add modules. You can choose your choice of accelerator, and you can set the expected runtime. And once you click on the preview button, this is what you should be able to see. So this is the job script that we have. So it just generates it for you. And from here, if you want to add more commands in the script, you can add it after this comment that is provided here. So I'll just give a demo on this as to how that you can reach to Drona Composer and how you can use it. So if you go back to the portal and you see the jobs option here. So if we click on jobs and we click on Drona Composer, so you should get a page like this. So you are able to set your job name. So say I'll give this like a name like this, and you can set the environment. So if we set the environment as generic, so you have a few features that I want to go over. So you can upload some files here, and you have these tooltips that you can hover over to see more details on what each of these fields mean. So you're able to generate your job script better, and you're able to do your work in a much more informed way. So you can add your modules here. So you can add any module you want, and you click on add, so it gets added. And if you want to remove it, you can just click back on this and it will be removed. You can set the number of tasks, you can set the number of nodes, you can use any accelerator you want. So say if I select Intel PVC, you can set memory, say I just select 1 GB, and say the expected runtime. So this is basically how much you want your job script to run. Say if you know that your job script will take maybe a day to run, so you can set it like a day. I'll set it to 3 days. And if I click on preview, so this is the job script that will be generated for me. So that was pretty easy. Now, one thing to note here is this yellow box that you're seeing. So this is a warning message basically saying that we requested a wall time of 72 hours, but the maximum allowed wall time on the PVC or GPU queues are just 48 hours. So it just takes care of that and it automatically sets it to 48 hours. And then you can add your commands here. You can type any command here and then you can submit your job script by clicking on submit, and you should get this message saying submitted batch job and this number. So this number is your job ID. So you should note your job ID whenever you're submitting a job, because you will be using this later on to see more details about your job status. Yes, Mohammed, the Drona is available on our other HPRC clusters as well. You can find it on Grace. Going back to the presentation. So this is again, I'm just going over the job script structure. So we just saw how our job script looks like, but I'm just going to go in detail about how a job script is. So it starts with a shebang. So this line is important. We need to keep this line so that when we submit our job script and it gets executed, it's able to identify the commands that we are writing. Then we have some specifications here. So you're specifying your job name here, so you can provide the job name you want. You're setting the time, the wall time here. So here it's like 1 hour, 30 minutes, but you can set it to more or less. End task is number of nodes, and so end task is number of tasks you're trying to set. Then you can set the number of nodes you want, the amount of memory you want to allocate to your job, and even the name of the output file that is generated after your job is executed. Then coming here, you can mention your account number so that whatever job is executed, the charges are reflected to your account. And after that, you can provide some commands here. These commands are basically to execute your work. And yeah, I think that covers the most basic job script that you can build. Going ahead, we'll do a hands-on activity where you can submit a job through your shell. And yeah, we're just going to go over that. So if you go back to the portal and we open the cluster, so here's the shell. And if you do, so what I want you guys to do is take note of each of the commands that I'm writing. So you can just copy this thing from here and you can paste it in your scratch directory. So just do this and you should be able to copy the file from your from from this path to the scratch path. So if we go to the scratch now, we are able to see the hello world.job here. So now what we're going to do is we're just going to run this command. So to run this job, we have a command called the sbatch. So to submit a job using our shell, you run this command sbatch and the name of your job. So before I go ahead and show you how to run this command, I want to know if you guys are able to follow so far and copy the file from this path to the scratch directory. Okay. If everyone is on the same page, then I'll go ahead and show how we can submit this job on the shell. So we just need to execute this command. So we go back to the shell and just do sbatch hello world.job. And if we hit enter, so you will see these two messages. So it just gives you your current balance, and then it also tells you that the job has been submitted with this job ID. So if you want to look at the job that you have submitted, you can do SQ -U and your net ID and your access ID. So since this job was a pretty small job, so it's already been executed. So there's one more command, which is not part of it, but I'm just doing it part of the presentation, but I'm doing it to show the status of the job. So as you can see that the state of the job is completed. And if you want to see, and you should be able to see an output, the output file, you can just do ls-al file. So here's the output file you see. This is the output file you see. So if we go here and check it out, so yeah, it's empty because we did not print out anything, but at least we can see that the output file is being generated. So that's good. Are you guys able to follow till here? If anyone's having any issues, you can let us know in the chat.
Actually, so for me, I've reached submitted bad job, so it gave me a number.
Okay.
What's next? Could you just
Sure.
continue?
So once you have submitted the job, what you can do is you can do ls-al, and you should be able to see all the files that are there in your current directory. And there you should be able to see a file named stdout dot whatever your job ID was. So when you submit your job, you should be able to see a job ID. So you should be able to see a file name which contains that job ID. So you can just, if you see that, that means that your job was executed successfully and you are able to generate that output file.
Yep, I can see it.
Yeah, okay. So yeah. So that was part of the demonstration on how to submit a job on ACES. Going back to the presentation. So we already checked how to use the command sbatch. We also checked how to do SQ. So SQ basically helps us to check the status of the job. So you might be able to see if your job is running for a longer time, you will be able to see your job, and it will be something like this. Now, when you submit a job, you use your SUs. So how do you check what's the balance of your account? So you can use this command my project, and you can just run this on your shell to get an output like this, where you will see how much of the SUs you have used or how much of it is pending and what is your current balance and what's your current allocation. So we'll try that out as well. So if we go back to the shell and just do my project, you should be able to see output like this. So for your account, you should be able to see your allocation, the used and pending SUs, and the balance. And you should also be able to see your PI. And if you guys want more information, you can just visit our knowledge base, and you can visit these web pages to get more information on SUs. And just a reminder, you can obviously check the same thing on the portal, and you can again request quota increase and even raise a help ticket from there if you are facing any issues. So I'll also show you how you can raise a help ticket on our dashboard. So if you go back to the portal and go to the dashboard, I think I should have it open here. So if you go to the dashboard, you can click on create help ticket, and you can just fill up this form and submit your request, and we'll be able to help you out. We have a whole team working on these help tickets. So you should get a response very promptly, and they will be able to help you figure out your issue. Going back to the presentation, I want you guys to just go to the dashboard and check for yourselves if you guys are able to see the information, and also please run this command my project on your shell to check if you are able to see the SU balance of your accounts. So we'll just wait here for 2 minutes for you guys to try it out. Please let us know if you're having any issues. Okay, looks good. And so if you guys need any help, you guys can always check out these links first. All of these links are part of our knowledge base. The knowledge base contains and all of the information that is related to our HPRC clusters. So you can just visit these web pages and find the information you're looking for. And even after that, if something is not getting resolved, you can email your questions to help@hprc.tamu.edu. We'll be very happy to help you out. And so when you're mailing us, please make sure that you are answering each of these bullet points, like which cluster you're using, your username, job IDs, location of your job file, any application you're using, any modules you loaded, the error messages, maybe the screenshot of the error message, or maybe the steps which you took to get to the error message so that we can reproduce the problem. So please make sure you do that. Thank you. That's all we have for today. And if you guys have any questions, we are happy to take them now.
Akashdeep, can you tell me again, like the default softwares that are available, the non-restricted ones, how can I access those? And what happens, like, for example, if I want to access one of the, let's say one of the softwares, I know you can access Python and like on through the shell, through the portal, but if I have to access it through the shell, how can I do that?
So if you're interested in any sort of software or application, what you can do is you can use the command module spider that we had shown you. So if you go back to this slide, you can see that we have spoken about module spider. So it basically helps you search for modules and their dependencies. So if there is a module available, I'm pretty sure we have the dependencies also available for it. And if there's some software that is not available on our cluster, you can just like place a software request. You can do that to the dashboard, or you can just mail us at help@hprc.tamu.edu. We'll get back to you and process your request, and you should be able to use the software afterwards.
Perfect. And so I did that. How do I get out of module spider? Like it's giving me like different. I can see all a lot of softwares. Um, it says like line 1 out of
Okay,
38.
so if you're getting something like that, you can just type WQ on your keyboard, and yeah, it should just
Oh, got it.
you exit out
Perfect.
of that mode. Yeah. Any other questions? So if you guys have the time, please fill out the survey for today's course. Like we have posted it on the chat. So please check it out. Please fill it out. It really helps us.
Hey Akash, I just have a quick question about the software installation.
Yeah.
Let's say I want to install some software, like right now I want to install FVBio. It's an open source software out of University of Utah.
Okay.
I want to install it on any cluster. I
Okay.
know I can request, right? I think you showed in the last couple of slides how we can request. And
Yes.
So can you please yeah, just explain that process? I mean, so is that gonna be accessible to all of the people, or is it just exclusively for me, or how does that work actually?
So if you go back to this dashboard, right? So we have this
Mhm.
dashboard on every cluster we have. So if
Mhm.
you're specifically talking about ACES, you just come to this dashboard and click on request software, and you can just fill up this form and submit it, and we'll just revert back to you on your request, right? And usually we are able to tend to your software requests. With the licenses, it gets a little tricky, but you just need to reach out to us and we'll help you with that. And other than that, if it's an open source software, you can always try to install it by yourselves on the cluster. You can use your home directory or the scratch directory, but do not use any sudo commands when you're trying to install.
Gotcha.
Yeah.
Thanks. Thanks. I appreciate it.
Yeah. Okay. If there's no other questions, I think that's for today. Thank you for joining us, and we hope to see you using our clusters. And if any issues are there, just reach out to us. We'll help you guys.